So, Achtung, jetzt kommt dann zum Durchschlag. Achtung.
Hello Internet. I probably shot some other footage showing how I built this circuit to drive a flyback transformer to make some high voltage sparks and things, and I wanted to explain the construction of that and how it all goes together and how you can change the frequency and therefore the resonance of the coil and therefore change what kind of spark you get. But what happened in the end was I found that video was kind of boring, and I wanted to show what makes me excited about this whole topic, and that's the sparks. So all we can do now is show some beautiful close-up footage of these sparks in action. What I have here is a glass of water with a lot of salt dissolved in it. I'm going to put the output of the secondary with a piece of wire into the water, and then I'm going to use the primary to make sparks and get some close-ups, and let's see what that looks like. Alright, so this setup is as follows. On the right hand side, this glass here, we have a glass full of water and some salt dissolved inside it, and on this side is just pure water. Now we're going to use the high voltage to show the interesting effect of how the salt changes when what the spark looked like when it comes into contact with water itself. And I've got a grounding wire going off to the other side of the coil, and then I've just got this yellow wire linking the two, so I don't have to move the grounding wire. It actually flows through the water. So let's see what that looks like with the lights out. One interesting thing to notice is the surface, how the unsalted water has a tiny corona forming at the end of each of the sparks, and the salted water has those distinct yellow points. Let's zoom in closer and see if we can get a real close look at that. Okay. Alright, super close up. Alright, now a close-up of the other one with the salt in it. I'm not really sure what I wanted to achieve with this video. It was more just to show how fun and how cool high voltage can be, and how many interesting things you can explore by looking at what it does, how it reacts with salty water or other objects. One more thing I'd like to show you is how it reacts with points on the cable, for example, the ends of it, and also these points here, which are just connected to the other side of the coil, essentially the grounding point, and how the little plasma beads, let's call them, form on the edge of that metal at the points, at the sharpest points, and they are the ones that first allow the spark to jump between them. So first I'll do it with the lights on, like it is now. And let me turn the lights off. It must be noted is that I can feel a strong wind coming from when it does this, when it sparks. You don't notice the wind so much, but as soon as you do this and you just have a plasma building up or this coronating effect, then it's so strong, this wind. Let me see if I can accentuate that because it's pretty beautiful. Let me see if I can accentuate that corona. Interesting, it certainly is difficult to capture that. And the other interesting one, of course, is the water. Because with the water, it does a similar effect. Voiceover Nils here, and I'd just like to say that the pictures that you're about to see, they were taken during the same sequence with the wire held just above the water, but just using very long exposure because I couldn't really capture on the film using the video. So with the long exposure, you can see that it's made up of many tiny tendrils of electricity, and some of them eventually arc down, but you can actually see how it's just a lot of really fine sparks coming out. And I guess it makes this kind of wind effect as well. So yeah, how plasma globes work, let me quickly show that. And there's obviously a vacuum inside that bulb. I can just move the slide. And when you apply the voltage, obviously one side is grounded and then it's going through the glass, there's a vacuum inside the bulb and there's filaments inside there. So as soon as you turn it on, you get this weird green effect, this weird light effect. Interesting, the filament's just broken. And now it's doing some weird shaking effect. Let me get the macro lens on there. The filament has snapped off and is now being attracted to the wire even when when the device isn't even on. So if I turn it on, it starts jumping around. And now it's off again. It's still moving. You can even hear it. On. Off. On. Off. Move the camera around. Let's turn the lights off as well. This looks pretty interesting. I was recently at the German Museum of Science, and there they have a demonstration high voltage where they describe the usage of glass, because glass is one of the best insulators. And this demonstration with the light bulb, which I'm currently doing, actually shows that. But let me insert a clip of that demonstration here as well.
Es ist einer unserer lautesten Versuche, daher bitte ich Sie jetzt alle, sich wirklich sehr gut die Ohren zuzuhalten. Please protect your ears. The demonstration is very noisy now. Achtung!
That filament is completely bunched up. Wow. That's crazy. Okay, let me put a wider lens on and show you these cool colors which come out of it. Further to the high voltage experiment, I wanted to see, I did an experiment with just plain water and with salt and water, that's table salt. but I thought, what if I make the most conductive liquid I could make? So I got to thinking the most conductive would be putting metal into water, for example. Well, that I can make here, of course. So I took this lens is focusing, hope I'm in focus. So I took the stuff that I use to etch my circuit boards, and I dissolved a whole lot of copper into this solution here. It's a lot of copper. It's about a handful of wire. I don't know, I didn't measure it beforehand, but it's a lot. The solution was saturated, I couldn't dissolve any more into it. And now I'm going to see, and then I took pictures with just the solution. I had pictures with salt, I had pictures with just water, and now I'm going to take close-up pictures of the spark as it hits this solution to see if there's any difference in conductivity. So let's see what that looks like. And just somebody will ask, I guess, the solution which I use is, I looked it up, it's N2S2O8, so that's sodium persulfate. So that's not just copper, of course, but there's so much in there that I can show you a quick experiment using a power supply, how fast the copper comes out of solution. It's completely saturated. It's really heavy now because of all the metal. Okay, what I got here, I have a piece of copper. I put that in there. It's just a conductor, it doesn't really need to be copper. I realized because early on I had the alligator clips in there. I'm just gonna do this quickly to show this. And then I've just got this piece of wire, old spring, whatever that is. I'm gonna put that on the other side. Okay, and I'm just gonna turn on the power supply. The power supply says 12 volts, and I've set it to 3 amps, but I doubt it'll get that high. So turn it on. Immediately the negative side turns black, it's releasing gas, and the positive side will form copper. 3 amps is flying. Let me turn up the voltage, see what happens. Okay, the voltage is now at the maximum of my power supply. 18 volts at 4 amps. Oh, my poor little alligator clip wires are getting really hot. So we've got 3.7 amps flying, so that's quite a bit. I'm going to just turn this off and see what we got. Look at all that copper that's... Sorry, let me focus this. Look at all that copper that's stuck to there. That's actual copper from the solution. And this side is clean. But that's obvious because the solution eats copper. I mean, anyway, when you're creating circuit boards. So that will be interesting after this experiment is done to see if you can take the copper back out of the solution. I mean, I don't think it's stuck on very hard. No, it's completely mushy. It's pretty gross, actually. Forms little beads. Alright, so on to the experiment with the high voltage. Okay. I put fresh water on top here, and it hasn't mixed with the rest of the solution. So now when I turn this on, the sparks are as though it's just in plain water. And as soon as I mix it, I presume it's going to go back to... Yeah, there's a little yellow sheet. Funnily enough though, they disappear after a while. Cool. Okay, so I made a small change. I added just a piece of hard copper wire at the end of the signal, the electric wire, and I was monitoring what happens, and I don't think it's as simple as what I see. I mean, the spark that's coming out of here now is completely different. It's much more focused and violent than those multiple strands of wire that was originally coming out of there. So maybe someone could explain what happens, but let me show you. It starts off small, starts off like we saw before, and then it focuses onto a point. Let me mix the liquid around a bit. Okay. It's a lot more violent. But you get a lot fewer of those burning points. And that's not beautiful. Let me get some photos of that. So I think we can conclude this here. If anyone would like me to try any other liquids, please let me know. But it's been fun. High voltage burst liquids. It's great. High voltage burst anything. I really enjoy it. So thanks for watching and have a nice day.